Question 7. Simplify the following expressions. Well, let's take number 1. We've got 1 minus cos squared here, and we know that cos squared theta plus sine squared theta is equal to 1, so we can replace this with sine squared theta. Sine squared theta under a square root means that we've got sine theta over cos theta, which is quite easily written as a tangent, and that's the answer to part 1. Okay, part 2. Cos 2 theta over cos theta plus sine theta. If we replace the cos 2 theta with cos squared theta minus sine squared theta, which is one of the standard identities, we can't quite cancel this at the moment, but if we look at this, cos squared theta minus sine squared theta is just the standard difference of two squares, so we can replace that with cos theta minus sine theta times cos theta plus sine theta. And we've got cos theta plus sine theta at the bottom, cos theta plus sine theta at the top. They can be cancelled, giving us the answer cos theta minus sine theta. Okay, question 3. We've got sine 2 theta over sine squared theta. So we'll start by replacing the sine 2 theta with the standard form, 2 sine theta cos theta. We've got sine theta here and sine squared theta here, so we can cancel a sine theta in top and bottom. So we've now got 2 cos theta over sine theta. Now remember, sine over cos gives you a tangent, so cos over sine gives you a cotangent, which means that the answer is 2 cot theta. Okay, part B. Without using a calculator, calculate the value of cos 75 degrees. Let me just remind you of these standard triangles. These are both right angled triangles. This has got a side 1 here and a side 1 there. So, by Pythagoras, 1 squared plus 1 squared is equal to 2 squared, so we take the square root of that, so it's a 1 root 2 triangle. So the cosine, which is this over this, is 1 over root 2. Cosine 45 is 1 over root 2. The sine of this, the sine of 45 is this over this, so the sine of 45 is 1 over root 2 as well. In this triangle, it was an equilateral triangle that we cut in half. Equilateral triangle has a 60 degrees in each corner, but we've bisected that angle, so that's a 30, so we've got a 30, 60, 90 triangle. This side is 2, this side is 1, so 2 squared is 4, 1 squared is 1, 4 minus 1 is 3, so this side here is root 3. So the cosine of 30, which is the angle here, is root 3 over 2, root 3 over 2. The sine of 30 is 1 over 2, sine 30 is 1 over 2, or a half. Cos of 30 is 1 over 2. Cos of 60 is 1 over 2. And the sine of 60 is root 3 over 2. Root 3 over 2. So we'll keep those in mind, because we've got 45 and 30 here, and we can break 75 down into 30 and 45. Now we can't just put the values in here. What we've got to do is expand this in the normal way. So cos 30 plus 45 is cos 30 times cos 45 minus sine 30 times sine 45. So using the identities from the previous frame, cos 30 is root 3 over 2, cos 45 is 1 over root 2, sine 30 is 1 over 2, and sine 45 is 1 over root 2. We've got a common denominator here of 2 root 2, 2 root 2, you see, and we've got root 3 times 1, which is root 3, and we've got 1 times 1, which is 1. So we can put that together, saying root 3 minus 1 over 2 root 2. And that's as far as you can go with this without using some sort of calculator.